Okay. Can you log in to the system? If you still cannot log in, you need to go into your system, change the password, and then check the system. So who still cannot access the system? Please change the password. Change the password. I think you have email to change password in your university email. So frequently, I'm suggesting every week checking the system email to check whether there are some informations. Okay. So have you tried to illustrate how the graphs looks like? Okay. Have you tried? Okay. What do you think the graph looks like? Yeah. Good. Good. This is correct. Your idea is correct. Yeah, this is correct. You can maybe check this first, how it looks like. So it will be 2 pi over k, right? 2 pi over k. So it's pi over 3, the period. The k should be only 6. Only 6 to k. So it should be 1/3 pi. Okay. But that's correct. I think, can you make zoom out? Can you zoom out? Yeah, yeah. Do you think, can you uh can you draw from 0 and connect all these points? What is that? This one you have, and this one. What is that? Here, it's the point here, the gray one, right? And you connect this, and it's like a curve, right? And you can also have a curve here. Do you know what is that function? It's the absolute value of x squared. You can add more functions, x squared, and add negative x squared. You will see the graph better. X. Wow. What happened? What happened? Do you know what? Can you? Where's x? Can you zoom out? Yeah. More. Or can you just make the erase this part? Yeah, erase that part. Okay. Mm, cos 6 pi x. I don't know what's wrong with your.
Is it
choice.
because I use this mouse, maybe try GeoGebra.
Yeah, I think GeoGebra. Yeah, yeah. Because I'm using GeoGebra to draw the graph. Should be okay. The functions. You can write pi in yeah. You get it? Uh, okay. Yeah, this is correct. Can you imagine if you dealing with this point here? Can you make a curve? You can make a curve. Right? You know what is that curve? Yeah, it's already here. It's this curve. Absolute value of x squared. It goes down and goes up. So this one will be the x squared. This one will be the minus x squared. Right? Hmm? Mm-hmm. Salah amplitude. Mm-hmm. Yakin cuma satu amplitude. Ini udah benar amplitude-nya apa saja. Okay. Anyone how to draw? At least just to see the graph how ours looks like. Okay. Okay. To see the graphs, look at the x squared at the front. Okay. Look at the x squared. Okay. The x squared is the amplitude, right? Right. So it will have positive a and negative a, right? So it will have x squared and negative x squared as your amplitude. But that's first thing to know. The other thing you can think like maybe you can just cover this x squared first. You can hide this x squared and think only the cos 6 pi. So cos 6 pi, you get first the period. Okay, the period is 2 pi over 6. It's just pi over 3. So you will get imagine your cos. Okay, your cos will be like this, right? This is your original cos. Okay, and then this should be 2 pi from here, right? Now this length will be shortened. Okay, shortened become pi over 3. Okay, so maybe this is pi. Maybe pi over 3 here. So it will be really, really. I need to draw bigger, but let's just use our imagination first. Okay. So from here, you need to make shorter and make it here. So, okay, get the idea? So you'll be having a really thin graph, okay? And it will going all the way if you just make the cos 6 by x, okay? But because you have amplitude of x squared and minus x squared, so for example, okay, if your functions become like this, okay, imagine this is just cos phi x, okay, imagine this is cos 6 pi x, okay, then imagine the top and the bottom will be cut will be cut down by x squared and negative x squared. So let's say we have here the axis. So you will have cutting here and cutting here. So the maximum will be only here, so it will be like that. Okay. And you don't need to exactly really detail in your drawing. Just illustrate what it looks like. So this is what it looks like. So this is the cos 6 pi x. Okay. And the blue and the green one is your amplitude. It's the x squared, and then the negative x squared. Remember, your amplitude should be in positive and negative. Okay. So if you think any functions, okay, similar to what I give to you, you can think the x squared as your amplitude, and then your cos 6 pi x will be cut with this whole amplitude. Okay. Yes. Yeah. Six is the k, right? 6 pi pi should be inside here, right? Right? Is that correct? Yeah. Right. 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 K should be a positive constant. Okay. And because it's not shifted, if it is shifted, maybe it's become pi x minus something. So the pi is in the x in this case. Okay. Let me check. One period. Oh yeah, yeah, yeah. Correct, correct. Uh, Dong, you're correct. You're correct. K should be 6 pi. Yeah, sorry, sorry. Okay, so the idea is uh, the amplitude. So this is actually really, let me write x squared cos 6 pi x, okay? So remember in calculus, you have the squeeze theorem, okay? So imagine this cos is always having a max a positive 1 and mean negative 1. So you can think from these functions, from the amount of maximum and minimum, you will have this, at least this inequality, in which when you multiply by x squared, you will get negative x squared and it is a good way to see from the graph where the x squared, okay, x squared, and then the cos 6 pi, and then the negative x squared, all located in terms of this inequality. Okay. Okay. So this should be fine. Okay. The other case is you can also have the cos 2 pi x and cos 16 pi x. So you can combine these two together. So the idea should be the same, amplitude and then the functions of the cos or trigonometric function. So the idea still be the same. So amplitude and then your functions. Okay. So if you think the cos 2 pi x as amplitude, we will have the positive and the negative one. Okay. And let me just show you the graph. Okay. So this is the graph. Okay. If you see, it has a pattern. Okay. And it has, I think, two patterns. So first is from the bottom, and the second one is from the top. Okay. That is the positive and negative from the amplitude. So our amplitude is cos 2 pi, right? If you see from the functions, let me just copy the words. So this cos 2 pi x, cos 16 pi x is this one. Okay. So the amplitude will be the cos 2 pi x. Okay. So there will be the positive one, like that, like here. So this is the positive amplitude, okay, or maybe here, and the red one is the negative amplitude, okay, and this whole thing is the amplitude, okay? And in amplitude you will have positive, negative, okay. Don't forget about that. But at least, okay, you don't need to be really specific about the exact point per point. At least the spatial angle, okay, 0 and 1 and negative 1, that should be able to help you to assume and predict the functions. Okay. Okay. Okay, that's the we say the all of this is variable. This is called the uh, variable, which means the amplitude is not always the same exact value. It will change along the way according to the function. Okay, I will skip all the tangent, cotangent, secant, cosecant. Just remember that every time you have sine and cos, for example, if you have sine 0, cos 0, it's defined, right? Sine is 0, cos is 1. So it should be at the you can look at the graphs. But when the sine is pi over 2, it becomes sine 1, it become 1, and cos pi over 2 is become 0, it become undefined, right? Which means you need to check your asymptote. So tangent, cotangent, secant, cosecant, it will have an asymptote when you divide with 0. And that's when you have the asymptote at that special angle or special degree. Okay. So I will skip off that because all property should be similar except the asymptote property. Okay, the other one is the inverse sine. Okay. So the inverse function, inverse trigonometric function. So we already draw the sine x. We also draw the cos x, right? Let's just say we draw the sine x. Let me just draw for you. Okay, more or less like that. Okay. If this is sine x, and maybe I can draw more to the left and to the right. Okay. Meaning it's having like in whole x-axis you will have the sine x. Okay. Can you draw the sine inverse x? But do you know inverse means? Inverse. Okay. Okay. Basically, inverse. If you have functions, you have domain and range, right? You have domain, you have range. Okay. In inverse, your domain and range will be switched. Okay. So in inverse, it's become range and it's become domain. Okay. But because it's switching, not all the functions will be having an inverse. And maybe it has inverse, but in some domains and range. For example, like I think in our quiz last time, I told you about the inverse. Okay, like you have the, for example, you have the f of x is x squared. Okay, let's just say this is y x squared, and then you can have y squared is x, and then you can solve the the y or solve the x, and you get the square root of x. Okay, so this is the, let me change. So f inverse of x is a square root of x, which means if you have square root, you're restricted to write your domain, right? You cannot write your domain in negative, right? So it will be correct in some domain and range, depends on the function. Okay, so we see the sine x. Can you make um, graph of sine inverse? Okay, let me move to new page to to see the drawing. Let me copy this sign. Okay. Now, if you want to make, for example, the this is x-axis, this is y. Let's say we switch the x and y to switch our domain and range. Okay. So this will be the value. So let's say this is 1. Okay. And let's say this is the -1 here. And our y-axis become the angle. Okay. Let's say we have this is 0. Um, let's say just this scale 5/2. This is -5/2. So when 5/2, the sign is 1, right? So we have point here. And we also have this point here. Okay. So maybe my drawing will be like this. So can we move on? Can we make this one? Who agree with this graph? Who agree? Anyone agree? No? Who agree with this graph? But can you answer what is wrong with this graph? What is wrong with this graph? Yes, correct. So every time you are doing or checking the functions, okay, the easiest way to check the functions is work in inverse or not, is taking vertical test. What does it mean? Here, if I have, because the sign, if we imagine the sign inverse like this, we will have, okay, if we take line maybe here. So here, line here. Okay. So when, or just saying when x is -1, what is y? It has this and this, right? Two value. In the functions, when you have that's those two values, it's not a law. It's not a one-to-one function, which means you cannot have an inverse like that. But okay, but there's a certain but, because I told you before that in certain domain and range we can have inverse. So let's just erase this part here. Okay, if you just think this function, it's okay, right? Because every x has s1y, right? This point is 1x, 1y, 1x, 1y, right? So based on our definition in the functions to be able to be inverse, then this is correct. Okay. So we need to restrict our functions. So uh, restrict the domain. Okay, restrict the domain. So domain should be only from -1 until 1. And range will resulting in negative pi over 2 and pi over 2. Okay. Based on these two conditions, we can have this as our sine inverse. Okay. Okay, so always remember f inverse exists if function is one-to-one function. And how to check it? You can use vertical test. What is vertical test? The one I just told you. Imagine a line in any x. If the x has 2y, then your whole functions cannot be inversed. But if you restrict only this domain, then it's okay. And also for cosine and tangent, you need also to restrict the domain. But I think I just going for the sine this class. Okay. And also remember, if you have uh, f inverse of f x, then it is you have f inverse of fx. It should be, who said that? What? X, right? X. Okay. X. Okay. That is the property of the inverse. And if you have the same thing, you have f prime x, it will be also x, which means, okay, from these two, you can play with some simple functions to prove this, okay? Which means from these two, your f and f prime, just switching the x and y, the domain and range, okay? Okay, I will move on, um, finishing our uh, trigonometry. So this whole thing, I will say it's trigonometry part A. Okay. Actually, we have A, B, C, but I will try to combine the last two parts into one because I think it's related. So the whole chapters in trigonometry is already three chapters in this book, but I'm combining and skipping some parts. Okay, so move on to the next one. So the next one should be the simple harmonic motion. I think it's better. It's understandable in physics, but I'm not sure about the physics this semester or next semester if they have the harmonic motions. Okay. So because sinus functions, cosine also, they have the, especially the sine. Okay, they have the periodic behavior. Okay, and we can see them as wave functions. So we can have our models, okay, based on nature, based on any physics phenomenon. We can simply write this down. So we can write this y a sine, let's say, should be the omega or y a cos. Okay, basically, in the principle, this is the same thing as we did before. Okay, amplitude, the period, and other things. It is it's the same actually, but we have another terms here, the omega, the like a W, but it's like a curve, have a curve inside. But anyone know what this is? What this is about? Yes, but can you elaborate what kind of speed? Yeah, it's angular velocity, right? But what define angular velocity? Yes, so this is the number of rotations every t. Okay, so you can say that this is the number of cycles, okay, every every time. Okay, can be second, minutes, hour, it depends. But the period is always the same. You can treat this as your k. Okay? So the a is amplitude. Uh, Period is 2 pi over the omega. So this is time for one cycle. And the omega itself is the angular velocity. So meaning how many rotation per t time. And then we have how many or how frequent. So this is number of cycles. So based on this phenomenon, we can imagine having a spring, for example, and the spring will move according to some functions, and we can measure. For example, we can write this maybe y is tan sine. Let's just use the available functions 4 5 like this. Okay, meaning this is the amplitude, and then this is the omega, the angular velocities, and then you can find the amplitude, period, frequency. Okay, and the same thing as previous slides. You can also can predict from this function how the graph will look like. If you're interested in um, maybe mechanical engineering and you want to deepen understanding in vibration, yeah, and you want to master the acoustic, like you want to understand the sound waves and then etc. This is the very basic concept for understanding the sound wave. I think vibrations is one section in mechanical engineering. It has their own lab, I think. They have their own specializations. So this is uh, the concept, the first, I think the first concept to understand the wave. Okay, and then this is just the simple harmonic motions, and we also have the shifted, which is basically similar to what we did before, but in the terms of omega. So a sine and then omega. Uh, Okay, basically you have a shifted in horizontal and shifted in the vertical. Okay, so shifted, horizontal shifted, and the vertical shifted. And the other examples, graph, etc., the concept is the same as before. Okay. But probably the examples would be you will have like a case, like a story, blah, 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 with some time, maybe some angular velocity, and you need to develop the models, and maybe you need to predict how the graphs looks like. As long as you understand the concept of the amplitude, period, how the graphs will be shifted, all the harmonic, either simple, shifted, uh, all will be the same. Okay. Okay. If I have time later, I will give you some examples. So this is shifted, and then we have also called it's called the damp harmonic motion. Okay. Anyone know what damp means? Damp, not dump, damp with A, not with U. Okay. Damp. Have you? I think you have lab tour to civil construction, right? Already, right? Last week, right? Have you got seeing the structure called dampened structure, right? You've got you see, right? What's damp mean in the civil construction? That structure. What it means? Remember the lab tour? Did they tell you about the structure? The dampened structure in civil construction. Do you get to see it or heard about it? Listen to the explanations from your. You get right? You see right? Or no? Okay. So the easiest way to explain the dampened structure is if you are in the building, then there's a earthquake. Earthquake is like uh, it's shaky, right? You can put into some models, right? It it can be sine, cosine, right? It can be model that going up, going down, right? And it's happened in frequent time. Okay? Dampened structure is how you are able to reduce this shaky into this, meaning there is no shake. You can, I think in the Taipei 101, have you go there? Going up? Have you checked there is the bowl, the bowl, okay? Do you know the functions of the bowl? Yes, that's also dampen, to dampen the motion. Okay? So damp harmonic motion is when you have sine, cosine having this wave, you want to reduce that wave. Okay, that's the idea. So if you have shaky, like really shaky like this, okay, you want to dampen. Like remember the functions you need to graph at the beginning of the course. It has the x squared. The functions at the beginning, the amplitude will cut off the functions, right? So we need to have functions to cut off this and making this into dampen uh, uh, to dampen motion. So, for example, if I have this and also this, I will reduce the harmonic, right? I will reduce the shaky, right? So the inside functions will be just, and then coming to almost zero, okay? That's the damped harmonic motion. So before we are going to write some formula here, can you guess what is the red color functions will be? Yeah, you can. So at least you need to have uh, some functions and a power, right? So we can have, for example, like x half, right? Or maybe half x. Is it okay? Maybe minus. And also remember, in nature, okay, there is one exponential that always happening. Yeah, it is correct. It's the E Euler number. Okay, so the E, because it happens in nature, it will be best fitted to reduce the harmonic motions. So we can write this. Let me write here. So y is equal k e or y k e. So k and this t minus, okay, this k e minus means it's the exponential function, but it's not growth, it's decay, okay, because it's negative. Okay. Remember the exponential growth and decay. So it's decaying, and it became the amplitude, okay, the amplitude. And depends on our models here. It can be sine, cosine. Okay. It will cut off the trigonometric functions. Okay. And the harmonic will be reduced. Okay, reduced. And C should be positive. We call the C is our damping constant. This is the amplitude, and this omega we can count the period, and the rest the same. How to graph, how we deal with the functions. Okay. The difference is the case for this harmonic motions, it will be dampened or the amplitude will be reduced. Okay. But do you have it in physics? No? Or will be? Or maybe next semester? Maybe it will be. Okay. I think at least in physics you will learn the spring, right? The spring. Okay. And I will show you the examples. This is the y equal e minus t sine 8 pi t. So similar to the previous one, you can see the sine 8 pi t first, and then you need to cut these sine functions with the e to the negative t. But remember, this is having absolute value. So you have the top and bottom. Okay. Okay. The next one should be I think the last one in this chapter. Okay. So the last section, it will be about the phase and phase difference. I think you will learn also in the physics and maybe some in mechanical if you go to mechanical route. But mostly it will be the electrical engineer learning phase difference. Okay? Because they will learn the wave and the characteristic of the wave. Okay, so phase and phase difference. Let me draw. Okay, okay. Just remember this is the circle. Remember the unit circle. So I will move from the x-axis and then rotate to the left. Let me make 2 points. Let me make a Q and then let me make P. And I have some angle here. Let's say I have Y is sine KT minus P. Okay. Okay. Let me give you some idea here. Okay. So this point Q and point P, imagine it's the moving object. Okay. So if these two objects moving together in a harmonic motions, um, you see that both of Q and P and Q, they have difference in the angle, right? Let me write at the initial time. Let's say the t is 0. Let's say we have sine is our minus b. Okay? So minus b is going from here to here. Okay, remember from the beginning of the unit circle. Every time we are going to the left, we are plus, 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 right? But when we are going clockwise, uh, back in time here, we are negative, right? So this will be our b, the value of b, okay? And when we translate this into our harmonic motion, let's say this b will be, let's start from p to the q, okay? Let's start from p, okay? Let's say we have here So we'll have going up. We make let's say the maximum is, so this should be, okay. So this is will be the P over K. So this means the phase angle is B, okay, and it will be horizontal shift B over K. We can also write to see what B over K is. Uh, we can factorize K, and this is what we get. So B over K will be our shift, horizontal shift, okay, from here. So if we think any two objects that moving together in harmonic motions, we can think them, they will have difference in phase, okay? And we can uh, see their period and how there will be difference. It will be in this B over K here, okay? So let me write this as this is the horizontal shift. P over K to right. And we can also think this B over K, because they will have difference as much as B over K. We can see this as, we can say this is lag time. Okay. Let's say uh, P want to move to Q. P want to move to Q. So P is behind Q. So this become lag time. P is behind Q, okay, by B over K units. But okay, this is if B is greater than 0. Okay. But you can also have the negative. Okay. If B is less than 0, this will be lead time, meaning now is Q or P is leading okay, by B over Q units. Okay. So phase difference. So whenever you find case that maybe two objects move together and they will have a difference in phase, meaning they both will have models in harmonic. Okay, if two, so I have two objects here, and they move in a harmonic motion. So maybe they move like this. Okay, it's harmonic, right? So when they move like this, you can translate these motions into sine or cosine, and you can find the difference between their angle in unit circle. We call that property as phase and phase difference. Okay? I think you will be more learning about phase in physics and other course related uh, to sound wave or vibrations. Okay? It's a difficult subject. I have colleagues who learn the vibrations because it's so for example, okay, you have some device, okay, or maybe some part from your equipment, okay. You need to check is your uh, equipment has a quality or not, or has some quality or not. Some of the quality check is you need to vibrate them. You need to put into some models, and then you need to check whether the equipment has a fault or not from based on from the data set of the motions. That's the first thing. I think mostly they will use it for laptop. So your laptop will need to check their QC. First is the vibration test. You need to check whether because the laptop, inside the laptop you have the chip, right? You have the silicon chip, and it was very small. If they are not integrated really well inside the laptop, after some time of vibrations, okay, maybe usually the test will take really long, like a weeks. Okay, so if the test fail, maybe some component they will broken down or maybe losing separated from the whole thing, then you need to redo your manufacturing. Okay, so that's why this is also important subject. Okay? So if you are thinking maybe you want to go for mechanical and you want to learn more about the vibrations, that's a special subject. And when you have that skills, many company will need you to use that skills. Okay? But now at least you understand the all the this a sine k something pi here. Okay? All the harmonic motions from the beginning is it has the similar expressions, and depends on the case and the examples that I'm giving you. You can have a lot of variations of case, but the concept is always this. Okay, so every time you forget about what's the meaning, go back to a sine k, just maybe just x, okay? Just x, and then maybe the x can be shifted minus something, and maybe it can be modeled with time. Okay, okay? So yeah, I think um, I think I will end up until here. Yes. Oh, here the models here. So it's shifted. Yeah, it's moving to the right b over k. You get it? So the original one should be should be here, right? The original one should be here, right? You move the red color here to the right b over k times. So b over k is the angle, like we deal with the minus pi over 3 before, right? So this is the same. So b over k is the angle that we need to move horizontally. Okay, got it? Here, we need to we have this k inside, right? The k should be here, right? Okay, so that's why at the bottom here, I'm confirming that the b over k is our phase difference. Okay, is that okay? Okay. Okay. Any questions? Anyone else? Okay. Okay. I think I will give you later maybe the practice if you need. But next week we're still in trigonometry. This one is unit circle. Next one will be the triangle and some double angle formula and identity and other identity.